Making vodka. Making vodka from white sugar is the simplest among other ways of making vodka, but having experience in making vodka from white sugar is important to understand how to use sugar effectively in making other spirits. Materials: 0.8 kilograms white sugar, 0.8 gal water, 1 teaspoon turbo yeast. Fermentation vessel, 1 gallon. The amount of sugar can be halved to increase the speed of fermentation. Indeed, the ratio of 1/2 for sugar/water should make the work easier. Alcohol percentage in vodka can be changed because distillation is done after fermentation. Fermentation. In the fermentation vessel, mix sugar and water. Add the yeast. Fermentation will finish in 7 to 14 days. Distillation. Distill in a pot still 2 times. In the first distillation, keep the head and heart, but discard the rest when the alcohol content becomes less than 20%, or when the boiler temperature reaches 98 C. In the second distillation, dispose the first 5% as the head. It is recommended to smell and taste the head before disposal. The amount of methanol is expected to be small because white sugar has no fiber that is the primary source of methyl alcohol. Keep the heart until the alcohol content becomes less than 20%, or when the boiler temperature reaches 98 C. Addendum. Further investigation. The question is how the initial sugar content before fermentation starts will affect the amount of alcohol. So fermentation was attempted with the following sugar per water ratios. A. 250 grams per liter, equivalent to 1 kilogram sugar per 1 gal water. B. 200 grams per liter, equivalent to 0.8 kilograms sugar per 1 gal water. C. 150 grams per liter, equivalent to 0.6 kilograms sugar per 1 gal water. After distillation, the distillate amount was A. 194 milliliter of 55% alcohol in volume. B. 190 milliliter of 45% alcohol in volume. C. 169 milliliter of 45% alcohol in volume. In weight, amount of alcohol per weight of sugar used are 194 times 0.55 times 0.78 equals 83.2 grams. 83.2 grams alcohol per 250 grams sugar equals 0.33 or 33%. 190 times 0.45 times 0.78 equals 66.7 grams. 66.7 grams alcohol per 200 grams sugar equals 0.33 or 33%. 169 times 0.45 times 0.78 equals 59.3 grams. 59.3 grams alcohol per 150 grams sugar equals 0.39 or 39%. This concludes that, with turbo yeast, fermentation consumed all sugar in each case. Also, experimentally we figured that the weight ratio of the produced alcohol to the initial sugar is about 33 to 39%. However, we are interested in the theoretical value of the yield. The chemical formula for the sugar to ethyl alcohol is C6H12O62CH3CH2O plus 2CO2. The molecular weight of the left side, glucose, equals 6x14 plus 12x1 plus 6x16 equals 192 g. The weight of the 2 moles of ethyl alcohol on the right side is 2 times 14 plus 3 plus 14 plus 2 plus 16 plus 1, equals 100 grams. The weight of 2 moles of carbon dioxide on the right side is 2 times 14 plus 2x16, equals 92 grams. So weight of ethyl alcohol divided by the weight of glucose equals 100/192 equals 0.52 or 52%. So the theoretical conversion rate is 52%. But our experimental values are 33% to 39%. Which is significantly lower. What are causes for the discrepancy? Possible causes include 1. Purity of sugar. which is highly doubtful. 2. Escape of ethyl alcohol during fermentation, which is likely but we cannot determine the amount quantitatively immediately. 3. Incomplete fermentation, which needs to investigate by repeating the experiments. Now we like to know what hydrometer would say to us. The sugar solution, C, namely 150 gram sugar per 1 liter water, was made again, and a measurement with hydrometer was made, which said the potential of alcohol is 6.5% ABV. Assuming that the volume of the solution after fermentation remains to be 1 liter, 6.5% ABV means 65 ml ethyl alcohol, which should weigh 65 ml times density of ethyl alcohol, 0.78 grams per ml. That means the weight of alcohol produced is 65 times 0.78 equals 50.7 g. The yield is 50.7 per 150 equals 0.33 or 33%. This agrees with our experiments. We have assumed that the volume of the solution after fermentation is 1 liter, which is an underestimate, but the error is probably small, or less than 10% of 33%. Therefore, the error should not affect significantly the conclusion we made. Thank you for watching this video. We hope to see you soon again.